This lecture video is on solving logarithmic functions. And so when we're solving logarithmic functions, really the easiest way to do it is to rewrite it as an exponential. And so on this first example, we have log base 2 of 16 equals x. And so if you rewrite this in exponential form, remember logs are equal to the exponent, so our base is 2. So it's going to be 2, and then we're raising it to the x power because logs are equal to the exponents, and then it's equal to 16. And so now we have an exponential equation to solve, which we've done before already. And so we need to figure out what power can I raise 2 to get 16, and the answer there is 4. So x equals 4 because 2 to the 4th power is equal to 16. In our next example, we have log base x of 64 equals 3. So again, rewrite this in exponential form. So the base of the log is x, so that's what's going to be raised to our power. And logs are equal to the exponent, so it's going to be raised to the 3rd power, and it's equal to 64. So now we can just take the cubed root on both sides to uncube that x, and the cubed root of 64 is 4. On our next example, we have log base 2 of 1 over 32 is equal to x, and so again we're going to rewrite this. So that's going to be 2 raised to the x is equal to 1 over 32. And so now I need to know what power can I raise 2 to so that I get 1 over 32. And so first of all, we need the exponent to be negative because that's how I'm going to get the number in the denominator here. And then you just need to figure out, well, what power would I raise the 2 to get the 32? And the answer there is 5. 2 to the 5th power is equal to 32, and the negative sign is what's going to make it become 1 over 32. In our next example, log base 25 of x is equal to 1/2. Again, rewrite it in exponential form. So that would be 25 raised to the 1/2 equals x. And so the 1/2 power really means that we're doing the square root of 25 equals x. And so that gives us x is equal to 5. And you would not do plus or minus. We didn't take the square root on both sides of anything here. This is just plainly the square root of 25. We weren't in the midst of solving something and then took the square root on both sides, so it's just the positive root. Back up to our next example here. We have log base 3/4 of x is equal to 2. So rewriting this, we get 3/4 squared equals x. And so we just have to square 3/4, and so we get x is equal to 9/16. In our next one, log base x of 81 is equal to 4. Rewriting this gets us x to the 4th is equal to 81. And to undo a 4th power, we would take the 4th root on both sides. And that would give us x is equal to 3. The 4th root of 81 is 3. And really, technically, because we're doing a 4th root, we would have plus or minus 3 here, but the base of a log has to be positive, and so we would only consider the positive root for this one. Log base 7 of 7 raised to the -2nd is equal to x. So you can either rewrite this one or you can just evaluate this log. And so what power could you raise this base to so that you get 7 raised to the -2nd? And the answer is -2. So basically we would be saying 7 raised to the x is equal to 7 to the -2nd if we rewrote it. And our last example here, again, we can just use the property of logs. We had a property that said if you have b raised to the log base b of x, that this is equal to x. And so we have the base here and this base of the log are the same. And so we know that this number has to match this number. And so x has to be equal to 8. But if we were to rewrite this, then the base of our log would be 9 because this 9 is being raised to a power. So it would be log base 9 because of that. And logs are equal to the exponent, so this whole log expression would be equal to this log because that's the exponent. And then we would be taking the log of the x. And so when you have two logs and their bases are the same and they're equal to each other, then what you're taking the log of has to be equal also. And that is the end of the lecture on solving logarithmic equations. So if you have any questions, let me know. Thanks.